friend to this session of interpreter pattern. In this session, we will try to understand what is basically interpreter pattern. We will understand the fundamentals of it, definitions, and a sample source code of it. So first, let's understand the fundamentals of interpreter pattern. Interpreter pattern belongs to the behavioral category of design patterns. So in this sense, it helps us to change the behavior of a project. Interpreter pattern allows us to interpret grammar into code solutions. Okay, now what does grammar means? First thing, grammars can be like the source code is a grammar, where you write your syntaxes, and the compiler is nothing but your interpreter, which actually interprets that grammar and develops a final output, either a DLL, either a exe, or the full compiled format of the project, or full compiled format of the source code. HTML is a type of grammar, and the browser is like an interpreter. So the browser runs on the HTML grammar, parses it, and displays displays the output in a browser in the browser. So in the sense, we have if we have a project of kind where we have some kind of grammar like a source code or a HTML parser, or we want to define some kind of like a query language, like if you look at like select star from table name, SQL query is nothing but a grammar, and your SQL parser, which can either be Oracle or SQL Server, whatever it is, it parses that logic and checks if the logic is proper and executes that to get a final output. So if your project demands such kind of condition where you have some kind of a grammar which you want to define and you want to make an interpreter, then interpreter pattern is a way for it, or interpreter pattern is a design pattern which can solve your problem. Let's take up a simple example. What we'll do is what we'll do in this project is basically we will try to define a date grammar, and in this date grammar we will by using this date grammar we can display any kind of date format. Means example, we can define a date into mmdd, we can define a date as mmddyy, we can define the date as yydd, we can define the date as just yydd and any kind of separator. So it's like, we are trying to define some kind of grammar which can be shuffled up and down, and the output and the final out the interpreter will run on that date grammar and display the date according and display today's date according to it. So the first important thing when we define a grammar is, or when we start designing the grammar solution in interpreter, is to identify the grammar elements, identify the self-contained logical grammar elements. For example, month is a self-contained logical grammar element. Hyphen, or we can say the separators of the date elements, are the self-contained grammar elements. Day is a self-contained grammar elements. So for every of these grammar elements we define their own classes. For example, for the month we'll define the parsing expression in class CLS month. For the day we will define the same into the parsing expression to CLS day, and so on. So basically for every grammar element we have a class, and the logic and the class has the logic to parse that grammar element. Now there are two important fundamentals when we implement interpreter pattern. One is the context and another is the logic. The context is a class which contains data. Okay, so it is the actual data, and the logic is which basically runs over the context and displays it in the readable format. For example, your context can be a HTML code or a HTML data, like bold tag. Okay, the logic is a Internet Explorer logic, or it's something, HTML parser or a Firefox. I don't know what kind of logic you're writing. That logic will run over the bold tag, the HTML bold tag, and display that bold tag in bold format in your browser. So in this sense, you have a logic and you have a context. Let's continue with the same date grammar class, the date grammar which we have discussed. And as I said, that we will be having separate parser for every grammar element. So I have a year parser, a month parser, a day parser, and a separator parser. And in every of these parsers I will pass in the context, the data. For example, this context will be, dd mmdd, whatever it is. When we see the actual code, you will understand what I'm speaking. And this expression class, like a day expression or a month expression, CLS month expression, CLS day expression, CLS year expression, will take this context and parse his own grammar element, and then whatever output he gets, he then gives it to the next month expression, or the next expression, who actually parses again. So every expression takes care of his own grammar element, and finally the whole grammar is built up, or the whole grammar is converted to a code solution. So here's the actual code implementation of the class which we discussed. So as I said, individual classes having their own grammar element parser, and a context object is passed to it, and then we have the parsing logic. Not to forget the context class which has the data, and you can see that that we have four expressions. Every of the expression takes a context, own parsing logic. Let's look into a source code of it. So here's what we have: CLS context, which has the context data. CLS expression, every we have like a year expression who takes the context data. Now because he is a year expression parser, he just sees where he can get y and then replaces it with the year value. Month expression takes again the context and see where he can get and displays the same. So in this way, every expression parser takes the context and deals with his own grammar element. So if you look at the make date, the UI which is using it, what it does is basically it says, okay, do I see a been passed as a passed as a grammar? If yes, then add the month expression. Do I see a dd? Yes, then I add the day expression. Do I see a year? Then add the year expression. And finally, just loop through all these expressions and evaluate it. So now let me run this project. So what I do is that I say, okay, dd and Now what it will do is that it will take this date and the month and display the today's date in that format. Then I can just say add probably just a YYY. Now you can see that it has displayed date, month, and year. I can probably just make it more complicated for him. Make it month, day, and year, and that's it. And I can probably make it more simpler and say, please just display me the year, and that's it. So what you can see is that I'm trying to pass him a grammar. The grammar can be a date, month, and a year, month, and a day and a year, or a year. And every expression runs through this context and passes its own grammar element and displays me the final output and the code solution. So as we I'm sure that once you have understood the code walkthrough, what I have done, uh, you would have got a feel of what exactly interpreter pattern is. First thing, interpreter pattern is a very rarely used pattern. This is very important to understand. So in case your project demands such kind of situation where you want to parse such kind of grammar, a complicated grammar, then interpreter pattern is the way to go. Don't don't use interpreter pattern for logics like probably where you have simple file parser, or where you want to do some kind of thing. If the parsing is very simple, don't use interpreter pattern, because it can lead to a lot of complications. If you find that there is some kind of grammar which you need to write, and that grammar and that every and the whole grammar has elements, self-contained logical elements, it's better to use interpreter pattern. Be very careful when you are choosing to implement interpreter pattern or not. The only question you should ask yourself is there some kind of grammar which needs to be changed to a final solution? Then only use interpreter pattern. I hope that I was able to make you understand interpreter pattern. Any kind of suggestions, any kind of feedbacks, or any kind of improvements in this videos are all welcome at shiv_query